My name's Andrew Kinney, and today I'm going to be telling you the story of a rather interesting and instructive and difficult feasibility study that's currently still ongoing here at PTI. So this was a study that we got in a couple months back on relatively standard 2R glass vials. The thing that made this difficult is that the product inside is embolic fluid, which means that it is related to the chemicals in our blood that are responsible for coagulation and stopping up bleeds when they happen and preventing you from bleeding more. AKA, it's very thick and it likes to clog. So we knew that any defects under the fill line, we're going to have difficulties with clogging, as that same coagulating effect happens as we try to pull the liquid out of any laser drilled defect sites. So we were already expecting going in that we were going to need to, at a minimum, drill our defects above the fill line and do headspace leaks so that we wouldn't have to interfere with the material properties of the liquid itself. The other product is the solvent that the embolic fluid actually sits in for preservation. And we thought that this was going to be a little bit more straightforward, as solvents are typically a little bit more alcohol or water-based and are easier to work with and don't clog as much because of that. However, this particular solvent is actually polymeric. This has an extremely low vaporization pressure, which means that we would have to get extremely close to absolute vacuum of 0 millibar, potentially even going into the ultra-torr range, to be able to actually vaporize this fluid once it egresses out of a defect site, to give us that increase in pressure that we're actually looking for during a vacuum decay test. So for those reasons, the original vacuum decay test wasn't very effective. Our second attempt was to use an E-scan, our microcurrent HVLD 615 inspection platform. Main challenge here being that we knew the solvent was flammable, so there was some potential that energizing the solvent and putting a voltage through it could cause a fire. So we had to put this in our shipping dock and throw up some fireproof blankets and stuff around it and open up the shipping door and give it a try first, just to make sure that we didn't blow everything up. Luckily, it does work, and rather effectively. We were able to get a good deterministic, repeatable method set up on it relatively quickly. So now the project is in a little bit of limbo, as the customer had some internal personnel turnover that led to a little bit of confusion on their side. So now they're trying to weigh whether they want to continue with the contract testing project on the 615, with the knowledge that if it is successful, which we expect it will be, they would be able to directly implement that testing process and test method into their production process if they purchase the 615. Or the other option, a little bit unconventional, but definitely available to them, is they can go back to the vacuum solution and actually test the vials empty and do a statistical sampling test method with the empty vials to prove that the container closure system itself is suitable and is working, even if we can't test it with the product inside. And that is completely acceptable, completely valid by all regulatory standards. So we're in a little bit of limbo right now, but we know that there's solutions available and the customer is happy and is still working with us, so everybody came out ahead. Thank you, and if you want to know more, always feel free to reach out to us on our website. Have a good one.